I wanted to make some videos of the examples I did during the online class session today. The first example was trying to go through the process you should think about when trying to sketch the graph of a polynomial function. So the first thing you should do is, if it's in factored form, is to think about the zeros of the function. So, if you have a factor x minus 2, then that would correspond with a 0 of 2. A factor of x plus 5 would correspond to a 0 of negative 5. And then the x that's here by itself means that 0 is one of the zeros of the function. And remember, the zeros are really going to tell you the x-intercepts. If the zeros are real numbers, they're going to correspond to x-intercepts. All right, next you should look for the multiplicity. Okay, the multiplicity really depends on the exponents on the factors. Okay, and the exponent on the negative 5 is 2, so negative 5 is multiplicity 2. This one has the x minus 2 factor has an exponent of 3, so it's multiplicity 3. And this one has an understood 1, so it's multiplicity 2. And the multiplicity really tells you what the behavior of the function is going to be at those zeros. So like, since 0 has an exponent of 1, it's going to be like a line. So like a line there. This one's going to be like a cubic. Hope you can read my writing. And then this one's going to be like a parabola. Okay. All right, so this one's going to pass through kind of smooth. Might be going up or down, we don't know. Okay, this one's going to pass through like a cubic, and it might be on the way up or on the way down. And this one's going to be a parabola, and right now we don't know whether it's up or down. Okay. All right, now, next thing you want to do is think about the end behavior. And so for this, you really need the leading term, and that is not obvious when it's in factored form. So you have to figure it out. So you need to come in and take all the firsts, all the beginning parts of this, including the exponents, right? And what you're thinking about is what would happen if I were to multiply all of these things out. Only don't really do it. You don't need everything. You just need the leading term. Well, you'd have a negative 3x to the 1, 2, 3, 4, 5, 6 to the 6th power, and then you'd have a whole bunch of other stuff. So since the leading term is negative 3x to the 6th, the end behavior of this polynomial is going to be just like y equals negative 3x to the 6th. And so what you do is you think of the fact that this is negative x to an even power. So it's going to be like a parabola that opens down because of the negative. Okay, so you're thinking this. All right, so now you have to put all these ideas together. So let's sketch the graph of this. So let me go ahead and get my coordinate plane. Let me put my zeros. They correspond to the x-intercepts. So it's going to cross at 0, 2, and negative 5. Okay. And then the end behavior is what I'm going to do next. Since it is supposed to open down, I know I'm going to come from below. And when I get to the negative 5, the multiplicity was 2. So it's going to bounce like a parabola. It's going to have to look like a parabola right here. Okay. Then at some point, I'm going to turn around and I have to go towards 0. And when I get to the x-intercept of 0, I notice the multiplicity of that one is 1. So as I come back to it, I'm going to go through like a line would, kind of smoothly. Right? But then I got to turn to hit this x-intercept. So when I turn and I start coming towards this, start turning towards it before you get to it, because this one has to look like a cubic function. It has to have that little kind of S look to it. And then see how both ends wind up being down like they're supposed to?